All right, so good afternoon, everybody. Welcome to class. So last time, we went over how to find the domains or range, from a graph, etc. So today, we're gonna try to find the domain, at least, the domain from like an expression, right? From f of x equals something. We want to try to find the domain. Okay. So sorry, that's what we're going to try to do today. So I'm going to, of course, share my screen. Okay, so if you say, find the domain, this is the domain of f is what is a set of all x's of all x such that f of x exists, you see? That's what you call the domain. Sorry. The domain is a set of all x such that f of x exists, okay? So if you can find f of x, then that x is in the domain. If you cannot find f of x, then that x is not in the domain. You see? So for instance, when we say find the domain, example, we say find the domain of f of x equal 5 over x minus 3, right? So we want to find all the values of x such that f of x equal to, f of x exists, okay? So since those x, they can be like trillions, billions of x's, right? It's easier to find all the x that are not in the domain, you see? It's easier to find all the x that are not in the domain. So here, when I look at my function, the definition of my function, 5 over x minus 3, right? The only thing I see here, the only major operation I see here is a division, right? I see 5 divided by x minus 3. And we all agree in math, we cannot divide by what?
X minus 3 or x
In math, we cannot divide by x minus 3, right? So in order for f of x to exist, the denominator cannot be 0, right? We all agree with that? The denominator cannot be 0, okay? That is my only worry here. I don't have another worry. My only worry here is the denominator cannot be 0, right? So I say here, for f of x to exist, here, x minus 3, the denominator cannot be 0, right? Agree with that? If I saw another thing, if I saw another condition, I would add it, but the only condition I see here is denominator cannot be 0, right? Okay, so in that case, we say x minus 3, you see? So x minus 3 cannot be 0, right? And obviously, if x minus 3 cannot be 0, then x cannot be how much? X cannot be, see, you add 3, say x cannot be 3, right? That is my domain. The domain is all the numbers that are different from 3, which is all the numbers except 3, right? So the domain is all real numbers except x equal 3. You see, so the domain here is all real numbers except 3, or we can write it, or you can write x not equal to 3, right? Or more importantly, how to write it as an interval, right? How to write this as an interval. You see, if you have, this is my number line, right? Negative infinity, infinity. Okay, I have 3 somewhere. I say, is everybody except for 3? 3 isn't only, right? How can I write this as an interval? Can somebody tell me?
3 comma infinity in brackets.
3 comma infinity, right? So when you say 3 comma infinity, just describing this one right here.
Oh, we would say negative infinite, 3.
Exactly, here we have 2 pieces, right? We have
Yeah.
3 comma infinity, but also we have negative infinity comma 3, right? The only number we don't want is the number 3, but everybody else we do want it. So negative infinity comma 3. So we have 2 ways, we have 3 ways to write the domain. You can write as a sentence, right? You can write this, or you can write this, the interval notation, negative infinity 3 union 3 infinity, right? This way of writing, which means x cannot be 3, right? You see here, again, for any function that only has a denominator like this, if you want to find the domain, right, for any rational function that is like this, if you find the domain, you focus on the denominator. We almost don't care about the numerator, right? We almost do not care about the numerator. So I'm going to give you some of them. So find domain and write as an interval. This is how you're going to see on the test. Find the domain. And write as an interval. Right? So we say f of x plus 9, right? G of x okay? So we have these 2 right here, and then another one. Okay, so we have 4 functions like that. So each one of them trying to find the domain, right? You see? And write it as an interval.
I'm in class, bitch. What you want?
All right, so everybody, so I'm gonna let you a couple of more minutes. Everybody, I want everybody, to try to come up with their own answers, before we go over it. It's very important, right? All right, so, okay, somebody who's gonna tell me what they did to find the domain for the first example? Who's gonna tell me that, please? Somebody.
Negative infinity.
Yeah, I mean that's so that's the final answer. Walk us through the steps. What you did.
Okay.
Go ahead.
F exists for 7x plus 9 different of 0.
Exactly. You see, everybody, the denominator cannot be 0, right? Okay. And then what you did next? You solve for x, right?
Yeah. You will negative minus 9.
Minus 9 on both sides, so you get 7x cannot be negative 9. So x cannot be what? Negative 9 over?
7.
7. Okay, now you're going to write it as an interval. What interval you got, Sherry?
Okay. Negative infinity.
Negative infinity, right?
Yeah. Negative 9 over 7. Union. Negative 9 over 7.
Yes.
Positive infinity.
Positive infinity. Thank you. You see, everybody, because this is a number line, which is negative infinity, positive infinity here. So we get negative 9 over 7 right here. And we get this. So we get this piece, which is negative 9 over 7 to infinity. And this piece, which is negative infinity, negative 9 over 7, right? Thank you very much, Sharif. Okay, somebody else. How about the next example, somebody? For the next example.
Okay, we will do the next thing.
Yeah, I mean, do I have somebody else before I let Sharif go? If somebody else is available.
I would set that whole denominator equal to 0.
Yep. You see, you get x squared minus x minus 20, right? You wonder this. You see, whether we set it equal to 0 or we set different from 0, it is the same thing, right? We just want to find those numbers who make it 0, right? Okay, which method did we use? Did you use to solve this?
This one was factoring. It would factor to x minus 5 and then x plus 4.
Exactly. Thank you very much. So which means the two x's cannot be what numbers? X cannot be what number?
X cannot be 5 and it cannot be negative 4.
Thank you. Great. You see, that is correct. And now comes the interval thing now. Now I have to exclude two numbers, negative infinity to infinity. I have to exclude -4 and +5, right? Okay. So how many pieces of inner wall we get then? If we exclude two numbers, how many pieces we gonna get?
You would get 3.
3 pieces.
Yeah.
This piece is how much? What inner wall is this piece?
Negative infinity. Well, parenthesis, negative infinity. And then -4 in the parenthesis.
Yep.
And then what is it? What is the thing you at the U that's in the middle?
The union. Union.
Yeah. And then you do -4
Uh-huh.
and you do 5
Yes.
and then you do another parenthesis and then you do another U
Uh-huh.
and then you do parenthesis 5 and then infinity.
That is
And
correct.
then parenthesis.
Thank you very much, both of you. All right, so we get, that is this one here. We have to exclude two numbers. So we came up with 3 pieces of inner walls, right? Okay, the next one now.
You set the denominator equal to 0, then you subtract, then you subtract 9 from both sides, then you take the square root of both of them and you get x equals 3.
Yeah, okay, so when you subtract 9 right here, -9 minus 9, so you get, you see, x squared is equal to -9. I agree with you. Now, when you take the square roots, remember what's gonna come out, because it's negative. It's I, right?
Yeah.
Plus or minus 3i.
3i. Yeah.
But in that context, in the context of functions, you see, x has to be different from 0. X has to be different from this. X has to be different from plus or minus 3i, right? In the context of functions, do we include in x, do we include the complex values like 3i? That is always true, right? X is always different from 3i in this context, right? X is, because x is a real number, x is always different from 3i, right? Because x is a real number. So x is a real number. So x is always different from 3i, or plus or minus, always. So then what is the domain then? Do I have anyone to exclude?
These are all real numbers?
All real numbers. Because the only numbers that worry me are plus or minus 3i. But they are not in the domain to begin with, you know? They are excluded from the domain to begin with. So which means I have nothing to worry about. So this is all real numbers, negative infinity, right? So which is all real numbers. Okay? Every time you solve the equation and you have I into the solution, then you don't have you don't have nothing to worry about. Okay? Same thing here. What is the denominator here? I don't have a denominator, right? But if I would write it, you know, if
it would be
I
1
as a fraction, it would be 1, right?
Mm-hmm.
Do I have any worries 1 becomes 0? Do you have any worries of that?
No.
We don't have no worries at all. 1 is 1. Doesn't matter which number you plug in, it's going to be always 1, right? Okay. So because of that, what is the domain then? All real
numbers except -1.
Now, because you see, 1 is 1. Nothing you can plug in up will make 1 become something else, right?
Mm-hmm.
1 is just 1. So I have no worries the denominator being 0, right? This denominator is always 1, you know? So because of that, my domain is all real numbers, okay? All right. So now, is the domain in general hard to find or easy to find? It all depends on the denominator you have, right? It all depends on that. So if your denominator is very easy, then the work is very easy. If the denominator is very hard, then the work gonna be very hard, right? So, but just if your function looks like this one, you have a fraction, you have a denominator, you don't have nothing else, you don't have a square root, you don't have cube root, you don't have nothing else, then the domain is, you just concentrate on the denominator, right? That's it. So now if you have another type of, another function here, if you say find the domain of f of x now is equal to square root of x minus 4. You see now here, my worry changes now. Do I worry about something being 0 or not? Do I worry about dividing by 0 here?
No.
Here we don't worry about dividing by 0, right? But what do we worry about?
The sign.
The sign. Thank you very much. Here we worry about having the square root of a negative number, because if we have a square root of a negative number, we have I coming out, and we don't want I to come out, right? Everybody agree with that? So in this case here, we say f of x exists if what? If whatever inside, if x minus 4 is greater than or equal to 0. Everybody agree with that? If whatever inside the square root is greater than or equal to 0, right? This is, I don't worry about something being 0. I worry about something being negative, right? You see, in that case, I solve an inequality here, okay? And then I solve the inequality. So I add 4, so I get x greater than or equal to 4, right? Which is here, if I have 4 here, so it's going to be this one. What is interval 4, infinity, right? Okay. So I'm gonna let you like couple of examples here. So if we say f of x, same thing, f of x equal to -3, right? What is the domain? And g of x equal to what is the domain? Go ahead. In each cases, you have to set the inequality greater than or equal to 0 in each cases, right? In each case.
Can I do?
Yeah. Yeah, I mean, you done?
Yeah.
No, wait a couple of, maybe like 1 minute or 2 for everybody to try, please. Thank you very much. And then we're gonna see. All right. What did you get? 7x minus 3 for this
Yeah.
one. Go ahead.
That x equals 3 over 7.
Is it equal?
No, it's x is greater than or equal to 3 over 7.
Exactly. Thank you. So it's 7x minus 3. You see, we said it greater than or equal to 0, and then we solve, right? So we add 3, so we get 7x is greater than or equal to 3, and then we divide by 7, so we get x is greater than or equal to 3 over 7, right? So what interval is that?
Is negative infinity, comma 3 over 7, and then 3 over 7, comma infinity.
Okay, look. So here we are mixing up the two cases, you know, the case before, which is x different from, right? Here is x greater than or equal to 3 over 7. If you put 3 over 7 here, what part of 3 over 7 are we talking about? The right part or the
We're talking about 3 over 7, then infinity.
Yes, thank you very much. It's 3 over
The right
7,
part.
right? 3 over 7, comma infinity, and this is closed, right? Okay, somebody else. So what did you get for the next one? We said negative 5x plus 10.
X
Yeah, go ahead.
is,
Go ahead.
I got x is equal to or less than 2.
X is less than or equal to 2, right? Thank you. So when you said this greater than 0, you are right. When you subtract 10, we get negative 5x is greater than or equal to negative 10. But remember, when you divide by negative 5, what happens? We have to flip the inequality, right? Everybody remember that? When you divide by negative 5, you divide by negative 5, you have to flip that, right? It's going to be x less than 2. So which is the left part of 2. So which is negative infinity 2 bracket, right? Okay. So now if you have this now right here, now what inequality we have to set now to get the domain?
X minus 6 greater than 0.
You get x minus 6 greater than
0.
Why we don't put greater than or equal to 0? Why you don't put equal?
Because when we put 0, square root of 0 is 0, and we can divide 3 by 0.
Thank you very much. Everybody understand that? This one here, we cannot put equal, because if you put equal, then we are messing up with the denominator, right? It's just greater than. You see, it cannot be 0, right? That is why we strip the equal, right? Everybody see that? So we get plus 6 plus 6, so we get x is greater than 6, which is interval 6 comma infinity, like that, right? Okay, so now if you have f of x is equal to cube root now. If you have a calculator, you can try the cube root of a negative number and see if your calculator will tell you impossible or possible, right? If you have a calculator, you can try the cube root of a negative number. Let me see if you guys can see my calculator. Okay, you can see my calculator, right? If I try the cube root of, for instance, let's say -8, you see, -8 cube root. The cube is 1/3 power. That is a cube root. You see, I get -2, okay? Which means cube root does not care about something being positive or something being negative, right? Cube root does not care about something being positive or something being negative. Because of that, because of the fact cube root does not care, what is the domain then? What is the domain then? Do we have any worries?
Is he glitching really bad for anyone else?
Yeah,
Huh?
for me
Yeah, I
too.
was just wondering.
Say again?
Still frozen for you guys?
Yeah, it's frozen.
Yeah.
So can you hear me?
Maybe it's the weather causing interference.
I mean, since this morning, it keeps telling me my internet, is breaking, something like that. I'm in my office, at CCBC, so maybe they have a weak Wi-Fi today. So now, but now, can you hear me now?
Somewhat.
Somewhat, yeah.
Oh, kind of, yes.
The videos started back up again.
Okay, okay. Let me try to use my phone hotspot and see if we're gonna change something. Okay. So. Okay, do you guys hear me?
Yes.
Yes.
You can hear me now?
Yep.
Okay, so I was saying cube root does not care about something being positive or something being negative, right? Okay, you see, cube root always works whether the number inside is positive number or the number inside is a negative number. Because of that, what is going to be the domain of this function that we see here? What is the domain of that function then?
I think all real numbers.
Exactly. Everybody understands the logic, why it is all real numbers? Because we don't worry about anything. We don't worry about x minus 8 being positive. We don't worry about x minus 8 being negative, right? We don't worry about that. It's not like square root, okay? Since we don't have no worries at all, so I'm going to go ahead and say the domain is all real numbers. You see, here we have no sign condition. You see, no sign condition. Because of that, so the domain is negative infinity, infinity, right? All real numbers. Okay? Cube root, any odd radical like cube root, fifth root, seventh root, etc. They don't care about the signs. Okay? They don't care about the signs. So now, if I have this now, it's going to be our last example in that topic. If I have this right here, f of x. Okay, look now. Please look at the numerator. Look at the denominator. And you have to write the conditions, right? And we saw each case, by the way, which we saw each case. I give you a couple of minutes for that.
Sir, say it again, please.
Say again?
Yeah.
So you done? Sheriff, you done, right? So we're gonna give like a couple of minutes for everybody to try to write the.
I got it.
Okay. All right, so, okay, so I'm not asking yet about the final answer, but what are the conditions for f of x to exist? F of x exists if what? Can you tell me, somebody, if?
X is greater than 9.
Yeah, I mean, that is the answer, right? That is the answer. So, but I don't want the answer yet. I want like the beginning. What are the conditions? If what?
It can't equal 0.
What can be 0?
X. Right. Wait. Yes.
Now, you see, if we focus on the denominator, we would say x minus 9 cannot be 0,
0.
right?
Yeah.
And what? If we
X
focus on the numerator, x
Yeah.
minus 5 has to be what?
Greater
Yes.
or equal 0.
Everybody see that? Now we have to combine both conditions now, right? On one hand, x minus 9 cannot be 0. On the other hand, x minus 5 has to be greater than or equal to 0, right? Okay, so which means x cannot be 9, right? On one hand, and x has to be greater than 5, right? Or equal to. And now I have to combine these two to get my domain. You see, if I have 5 here somewhere, and I have 9 somewhere here, first I say x has to be greater than 9, right? I mean, than 5, which means here. But x cannot be what? X cannot be 9. Everybody see that? In blue, x is greater than 5, right? In blue. The circle around 9, which means x cannot be 9, right? So what is the domain then? What is the interval? Bracket 5, 9, parentheses, union, parentheses 9, infinity, right? Everybody see that? All right. So these are few cases, you know, in 163, few examples where we can ask you about the domain, right? Few examples. Okay, of course, you know, when you do math, every time when you do math, you're gonna deal with a lot of functions, right? F, a lot of functions. And when you deal with functions, you always have to find the domain first, right? Always you have to find the domain, okay? All right, so we want to tell about that a little bit. So now we say how to find increasing functions and decreasing functions. Okay, so you know, a function is increasing is whenever you increase the input, the output increases, right? That is called an increasing function. Whenever you increase the input, the output increases, right? Okay, for instance, if my function is, you know, the amount I use in my power, you know, how much I use the power in my house, that is input, and my output is a bill, is my BGE bill, right? The more you use, what's going to happen to your bill? To your bill?
Going to increase.
Your bill will get higher, right? The more power you use, the higher is going to be your bill. That is an increasing function. There is an increasing dependency between the input and the output, right? Okay, they vary the same way. If X increases, Y increases, right? Okay, so a decreasing function is all the way around, right? the more the input X, the less the output, right? Okay, the more the increase, the more you increase, the more X increases, the more Y decreases, right? For instance, if we say the age and the health, right? Yeah, I mean, if you're talking in general, right? The age and the health. If the age is the input, is X, right? What happens when you age, when somebody ages? What happens to the health? In general, the health declines, right? Exactly. That is a decreasing function. So we say f of X, f is increasing. If you have two inputs, f of X1 is less than f of X2, whenever X1 is less than X2, right? You see, the increasing function respects the order, right? The increasing function respects the order. If you increase the input, the output increases. If you decrease the input, the output decreases, right? Okay. F is decreasing now, is the other way around. When you increase the input, the output decreases. So can somebody tell me what I'm going to write, the same stuff I'm going to write here? Can somebody tell me? Is f of X1?
Great.
Yes, go ahead.
F of X1 is greater than f of X2.
Whenever what?
Whenever X1 is whenever X2 is greater than X1.
X2 is exactly whenever X1 is less than X2, right? Which is the same. Okay. So decreasing means when you have two inputs, when you put them in the machine, the outputs don't follow the same order, right? Okay, that is a decreasing thing. So again, in math, so we are just in 163. It's not very easy to prove in general that a function is increasing or decreasing. It's not very easy to prove it in general, right? With algebra stuff. And we don't have the tools in 163 to do that. But graphically, when the function is increasing, graphically it's very easy to tell. When the function is increasing, the graph goes up from left to right. When the function is decreasing, the graph goes down from left to right. You see, for instance here, if you have A, B, this function is increasing, is going up from left to right, right? So you see, f is increasing. On AB. Why? Because it is going up from left to right. Okay? And increasing functions, the graph of an increasing function goes up from left to right. Okay? Everybody? The graph of an increasing function goes up from left to right. What about the graph of a decreasing function then? What is your guess? When a function is decreasing, how's the graph going to go? The graph is going to go down from left to right, you see? So this is, f is decreasing. Okay? So graphically, it's very easy to tell when a function is increasing or when it is decreasing graphically. Algebraically is not as easy as that, okay? Graphically it is, but algebraically is not, okay? So that is in 163, we don't do the algebraic stuff, okay? We're just gonna deal with graphs. So now, if we have a graph now, right? If we have a graph now, we're gonna say if, you know, I'm gonna have the textbook out, get some graphs out, right? Okay, so look, right here. This graph right here. And when the function, I have to tell you, when the function is straight, when the function is like this, it does not go up, does not go down, how we call that function? Is this function increasing? Is the graph going up? No. Is the graph going down? No, right? So this function is constant. It is not going up, it is not going down, right? So right here, if we come back to this graph right here, how many times this graph is going up?
Two.
2 times, right? So how many times this function is increasing then?
2.
This function is increasing 2 times, right? So we're going to try to see when this function, on what interval this function is increasing or decreasing. Let me paste copy here. You will see it's very easy to read, right? My function is increasing twice, right? So what you're going to see on the test, you're going to see, for instance, find the x intervals, right, where f is increasing, for instance, right? Okay, this is what you're going to see. What are the x intervals where f is increasing, which means where the graph is going up? We all see clearly the graph is going up from here to here, right? We all see that. It was the first time the graph is going up. But what I will follow? Do I follow the points or do I follow the axis? I follow the axis. From what x to what x? You see, the graph is going up from this x to this x. Everybody agree with that? Okay. So what is the first interval where the graph is increasing is from this x to this x right here, right? From -5 to -3, okay? All right, so f is increasing on the interval -5 and -3, right? What is the other interval where f is increasing? From what x to what x?
1 to 2.
From what x to what x?
1 to 2.
1 to 2. Thank you very much. Everybody see that? From 1 to 2. You see, because it is increasing here, but like I said, I follow the axis 1 to 2. So union 1, 2. So here, contrary to the domain here, if you close them, I will agree. If you open them, I will agree, right? For here, you know, we open the parentheses, we put parentheses, okay? Okay, now, find the x intervals where f is decreasing now. F is decreasing on what interval? Okay, think about it. Tell me what's the interval. From what x to what x?
2 to positive infinity.
From what x to what x? F is decreasing.
2 to positive infinity.
2 to 6.
2, okay. It's very interesting. You said 6. You see, Why we don't stop only at 6 here? Why you have to keep going? What tells me I have to keep going?
Oh, the arrow.
The arrow. The arrow tells me I have to keep going. But we understand it starts from 6, right? You see, my function here, I mean from 2, is decreasing in this stuff right here, and it has to keep going right here. So it is on 2, infinity, right? Okay. In this interval right here, f is not increasing, f is not decreasing, f is constant, right? On the interval -3, 1, f is constant because it is a flat line, okay? If I see that, so graphically, this stuff, they go, the answer is like real quick graphically talking, right? So let me see if I can get you another graph. Okay, so this graph right here, tell me f is increasing on what interval and f is decreasing on what interval for this graph, please, everybody. So I'm going to insert it here. F is increasing on what interval? F is decreasing on what interval?
From 2 to about 4.3.
Everybody, don't forget to write your name, you know, for the attendance, please. If you haven't done it yet, you know. If you haven't done it yet, so. All right, so f is increasing on what interval? Everybody, f is increasing on what interval?
2.3 to 4.3.
Increasing on, you said 2.3 to?
4.3. Because it's not exact on either.
Yeah, it's not exact, but here I'm saying increasing on, going up.
Oh, to infinity, my bad.
Okay, you were answering the decreasing, right? Okay, the increasing is what is the interval? The first time f is increasing is here,
Oh,
is this piece right here, right? And this piece is from what x to what x?
Negative infinity to
Negative infinity all the way to the
1
this
over
x
2.
right here, right? Which is negative 1 point something, right? Okay, so it's going to be negative infinity all the way, let's say negative 1.5, just just to make it exact, right?
I'm not confused. I thought the down arrow meant it was decreasing.
Yeah, so this is increasing this part, and this part also is what? Increasing, right? It's going to be what then? 0.2. I mean, let's just say 2, okay? 2 to what part? What? Union 2 comma infinity, right? That is the increasing part. Where f is it decreasing?
1.5.
Negative 1.5 comma
2.
2, right? Thank you. Okay, so increasing is the graph is going up, decreasing is the graph is going down. Now, obviously, do we even have to explain when where the graph is going up? I don't think so. Everybody sees where the graph is going up, right? Everybody sees where the graph is going down. That is not what you have to explain. We have to explain how to write your answer, right? Okay, your answer should be an x interval, right? Okay, everybody sees clearly my graph is going up from here to here. Everybody see that, okay? But 50% of students will write the answer in the wrong format, okay? You have to write your answer as an interval of x, okay? Everybody, you have to write your answer as an interval for x, okay? John does say, from here to here, etc., etc. You see, if you want to get the point, you have to write your answer as that. All right. So, yeah, so that is, graphically last time. So just, just before you go, what is the domain of this function? Real quick, that you see. What is the domain?
Negative infinity to positive infinity.
Everybody see that?
Yes.
Everybody sees the domain is negative infinity to positive infinity. What is the range also?
1.5, negative 1.5 to 2.
No, the same thing. Negative
Oh,
infinity.
it's the same thing.
Positive infinity.
The range also, because of the arrows, right? Because of the arrows. Now, if I don't like the arrows anymore, right? You see, if you don't like the arrows anymore, so let me do this. Let me copy again and then change it, right? And then ask you about the domain and the range now. Okay, so if I do that now, okay, now everybody now, I stop my graph here. I stop my graph here, and I stop my graph here. Okay, so this piece is not part of it anymore. What is a domain? What is a range? What is a domain? What is a range?
The domain is -4 to +4.
Thank you. I see -4 to +4 because my graph start with -4 here, all the way to +4 here. So now when I write it this way, is this an interval yet?
No.
No, it's not yet an interval. What do I put before -4, a bracket or a parenthesis?
You put a parentheses on the left side and a bracket on the right side.
Thank you very much. Everybody see that? The parentheses come from the open circle and the bracket come from the closed circle, right? Okay. What is the range? From what y to what y?
-5 to
-5, comma what?
+3.
+3. You see, my range goes from here all the way to here, right? So now, is it open or closed at -5? I think it is open, right? Is it closed at +3? I think it is closed. It's -5, +3. Okay. All right. So I think, you know, graphically, this is, we could have said graphically about a function. So when we come back next week, so we're gonna do, you know, we're gonna try to graph some functions, some of them, not a lot, you know. What is the graph of a linear function, square root function, parabola, cube root, etc., etc. And then we're gonna have to see what transformations of graphs, how we transform a graph, right? We're gonna see that next week. So we all know that our first test will be, if I'm not mistaken, October the 5th, right? Something like that. Okay, so our test number 1, you see, that is on the syllabus, right? October the 5th. You see, which is like two, you know, right here. October the 5th, right? So next week, I'm gonna put a review sheet on Blackboard, right? You know, the review sheet will just show you what are the topics. But if somebody really wants to review, you know, the review sheet will be about few problems, right? If you want to master a topic, you don't have to do only 2 problems for that topic. If you want to master a topic, you know, you can do 20 of them, right? If you have time, okay? You see, for instance, if you want to master how to use quadratic formula, you know, you don't have to do only a couple of them. If you have time, you can do like 20 of them, etc., etc. You know, and so the review sheet will be more of what are the topics, okay? But if somebody really want to practice, you can practice the review sheet, and you can practice more than the review sheet, right? If you are done with it, if you did all the problem with it, you can do more, right? So test number 1, please prepare for the test. The quiz was worth only 5%. A test is worth 15%. You have to do the arithmetics, right? Always do the math. A test is worth 15%. So if somebody is planning to have an A in this class, you have to do good on the test, okay? If you want to have an A in the class and you get a C in one test, then then your A is jeopardized, right? Okay, that is just logical. So, all right, everybody. Do you have any questions about this? Everybody wrote their name?
I'm gonna take a picture of it.
Yeah, so, okay, you want me to share screen? Yeah, that is on the syllabus right here, everybody. You know, we always have to have an eye on the syllabus, right? because you have the calendar in the syllabus. Okay. All right. So see you next week. So do not hesitate, Alex. You know, the Alex, whether we like, somebody likes Alex or don't like Alex, right? It is worth 10%. And that is what I put in my head. It's like 10% of the grade. You see? So you have just to deal with it because of that percentage, okay? And if you have questions, you can always reach out to me, you know. All right, everybody. You have a nice week. Thank you very much.
Bye.
Thanks.
Thank you.
Thank you so much.
Bye. Thanks.